This is from Projectile Motion Problem Set and number 5. At her wedding, Tracy lines up all the single females in a straight line away from her in preparation for the tossing of the bridal bouquet. She stands Beth at 1 meter, Adrian at 1.5, and Shannon at 2, Kristen at 2.5, and Marcy at 3 meters. Tracy turns around and tosses the bouquet behind her with a speed of 3.9 meters per second at an angle of 50 degrees to the horizontal and is caught at the same height 0.6 seconds later. The question is, who catches the bridal bouquet? In order to solve for this example, we're going to sketch the following. If Tracy is standing and throws the bouquet 50 degrees to the horizontal, the bouquet is going to travel in somewhat of a parabola. We know that she throws it at a velocity, at an angle velocity of 3.9 meters per second, and the angle, or theta, is going to be 50 degrees. The question is, who catches the bridal bouquet, or what is the delta x in the x direction, which is also equaling to the range. So who's going to be on the other side? In order to solve for the following, we're going to label. We know that velocity, the resultant of the velocity, is equal to 3.9 meters per second. We also know that theta is equaling to 50 degrees. We know that it is caught 0.6 seconds later. Therefore, time is equal to 0.60 seconds. We first need to solve for the following. We have right here a right triangle. Again, we are looking for the delta x in the x direction. Therefore, with given the 3.9 meters per second, the resultant, the velocity of the resultant over here, we are able to also solve using cosine of theta equaling adjacent over hypotenuse. If I rearrange this formula of hypotenuse times cosine of theta, I can find the adjacent side, or this side. I'm just going to plug in what I do have. I know my hypotenuse, or the resultant, is 3.9. I know what theta is equaling to, which is 50 degrees. Therefore, I can find the adjacent. And through calculations, that comes to 2.5 meters per second. That is the first part of solving this step. However, we need to solve for the second portion. We know that, and we're looking for the delta x in the x direction. We know that velocity is equaling to delta x over the change in time. We have the velocity in the x direction to be equaling 2.5 meters per second. We also have the time. Time is equaling 0.60 seconds. If we rearrange this formula to solve for delta x, I can get delta x is equaling to time times velocity. Therefore, delta x in the x direction is equaling to 0.6 times 2.5. Therefore, delta x in the x direction is equaling to 1.5 meters, which means Adrian is going to catch the bouquet.